That's just how we're wired. We all want to make the most amount of money we can per hour. So the storyline goes that she makes a certain amount working after school. Is after school weekdays, at least in America? Monday through Friday? Okay. So weekdays, she makes $5 an hour. You need to be in your notes. Absolutely not doing that. On Saturdays, how much does she make? 6? Okay, so you guys have just filled all that in. And how many hours she works multiplied by her rate, dollars per hour, will give us her income for that particular scenario. Like Saturday's income will be hours worked on a Saturday times 6. Weekdays income will be Monday through Friday hours worked times 5. She worked a total of 12 hours. How can I extrapolate what one or the other is? They say Saturday is S. If Saturday is S and we know the total is 12, and this is one of the trickiest things to muster, and every year when I teach this, I wish there was a different way to teach it, but if you know a total and you have a variable, the other one is the total minus the variable, okay? And you could practice that using real numbers and kind of testing it out for yourself, but in a nutshell, if you know a total and a variable, try putting an E there, then the other OTHER is total minus whatever the variable is. In this case, they chose S. Doesn't really matter, though. You can choose whatever you like. From here, we can extrapolate some information. We can extrapolate that our income for Saturdays is $6 multiplied by S hours. We can also extrapolate that our income from weekday working is $5 times 12 minus S hours. And you need to be filling this in your notes. Charting is not natural to anybody, but practicing it helps. We also know a total for her income, don't we? Doesn't seem like very much money, does it? How much money? $64.50. Yeah. So $64.50 is the result of her Saturday income added to her weekday income. The sum of these incomes, according to the story problem, produced $64.50. The story wants to know how many hours she worked on Saturday. Okay, this is what we're searching for. So once we solve for S, we actually have the answer.
Dylan Hanson to the office, please. Should be leaving for the day.
If they wanted to know his weekday total, we would just subtract that S value from 12. Anyways, once you're here, most of you can probably solve distributing and then combining like terms. Notice I combined my S's there. A positive 6 S's combined with a negative 5 S's resulted in an S. From there, if we subtract 60 from both sides, the number of Saturday hours is 4.5, otherwise known as 4 hours 50, or 4.5 hours. 4.5 is 4.5 hours. Okay, notice they're looking for time. 4.5 is 4.5 hours. Time was what they were looking for there. All right, Ernesto and his stamps. We'll deal with that here in a second. Read through that problem with me. This is example 2 in the orals. And I'm going to start with my chart here. All right, stamps. Ernesto purchased 100 total stamps. He had 100 stamps. That's a quantity. This here item means quantity, how many of something. And the value of the stamps was $9.90. Half of them were 1-cent stamps. So half of 100 is how many? 50. We can fill that in as data we just figured out because the story says half of the 100 were 1-cent stamps. So using that information, we know we have 50 1-cent stamps, and I just plugged it in. By the way, what is a 1-cent stamp worth? A cent. Now, notice in their little hint, they said instead of using 900, or use 990 cents instead of 990. So that means instead of using pennies as in hundredths of a dollar, I'm going to do everything as in flat coins. So instead of 1 cent being 1/100th of a dollar, I'm just going to do a 1. The total value of 50-cent or 1-cent stamps is going to be 50 cents. Okay, does that make sense so far? The rest were 14 and 22 jobbers. So the total number of these is how many stamps? 50, good. Very good. So if I call this one, and in their book they do, this one is X, then what must that one be? Using the rule from before. If you have a total and one of them has a variable, what's the other one? Yep, total minus the variable. Now we can fill in our prices. It was a 1-cent jobber, it's a 14-cent jobber, and a 22-cent jobber. We know we have 51-cent stamps, so the value is 50 cents. We know we have a total of the 14ers and 22ers of 50. They called the 22ers X, which means the other one is 50 minus X. Count multiplied by their price per item is the total value. So this one here is 14, 50 minus X, and the other one is 22X. The sum of all three of these is 990 cents. All we got to do now is add it all together. 50 added to 14, 50 minus X, added to this here 22X must be equal to 990. Distribute, combine like terms, etc. What's 14 times 50? 700 flat? Combining again, 750, negative 14, so that's 8x. Combined my numbers here, my variables here, isolating X first by subtracting 750. So what, 8X is 240? Good. And that stands for 22-cent stamps. So that means there are 30 22-cent stamps. We know that because X represents 22-cent stamps. Is that what they wanted? Why, yes it is. Lucky for us. What if they wanted to know how many 14-cent stamps? Yep. Yep. So if we wanted to, we could say there are 20 14-cent stamps. Okay, this was the only answer they really wanted, but we do have access to that second answer because of the first answer. Today is odd. If I do not see work and charts and stuff, then I'm just going to assume that